So I gotta make a robot walk, but what it's gonna be is like you write one algorithm. The algorithm has to work with both the robot and the guy on the screen.
Okay. That sounds good.
Or I guess the reading using Alice for the walking algorithm. So there's different ways that we try to do this. Alice is actually very hard to work with in terms of creating a walking algorithm. So me, Miles, and Joseph kind of worked with me. And we think we came up with one way that this could happen. So I'm going to play it for you. Now, one thing that I don't understand, it stops for some reason in his walking. Here you go. So basically, that's him walking, but he's not supposed to stop. But for some reason, in the loop, he stops, which doesn't make any sense.
How many poses did you use?
He's not on actually, so I need to write it again. That's what I want.
So this is GameMaker loaded. So when we actually start it and we hit left, it's going to activate. The room should activate the robot.
Okay, so when we run the game, you're going to hear the robot make a sound, and that's telling you that the robot is actually on and it's been connected to. So he does this initial stance, so he shifts his legs, and I found that makes it a little bit better for him to start walking. The only problem is at the end, I kind of want him to shift back, but he doesn't do it very well, so you kind of have to reset it by hand at the end. So what you see on the screen is the console for the program that's running the robot, and you can just see some basic information about the robot. It tells you the battery level, it tells you what the software is running, and it tells you the part that's important to me as a programmer, the starting position of the legs, and you can see that it's just an integer in degrees. But what I found out in programming the robot is it doesn't go between 0 and 360. It keeps incrementing. So you can get a number like 1,000 something, which I thought was strange, but it relates to how many times the motor has rotated since the motor was turned on. So in the future, we're going to have to do something with that math. So
for some reason, I don't know why, just now, all times with the game, the man didn't show up.
Yeah.
I don't know why the man didn't show up.
So when I press the left arrow, he'll shift positions.
So keep in mind, this is all run through GameMaker. So
and the same thing will happen with the right arrow. So you can kind of see his leg rotating around. So one of the hardest parts of this was actually getting the walking algorithm down. So so you can see him actually take a step forward. So the way he's programmed, it shifts the motor by a certain amount of degrees, and when you press an arrow, it'll shift that motor. So
oh look, now he shows up.
So this is an example of you can't run both the programs at the same time. So
no, well yeah,
like they run at the same time, but you can't have both windows running things at the same time. So we can press the left and right arrow keys on the screen and the guy moves left and right. So one of the hardest parts of this was just getting him to walk in the first place. Like I said, I had a header file which had like 50 functions in it, half of which had like hexadecimal numbers in it and stuff like that. So I had to figure out how every function worked and exactly the correct amount of degrees to rotate the leg, as well as the correct speed at which to rotate the leg, because the different speeds with the degrees makes the leg do something differently. So if the speed is too high, it might actually rotate, for example, more than 180 degrees, like 190, 200 degrees. So we found out that something different happens every time we turn the robot on and off. So sometimes it'll actually walk 100% correctly, and sometimes it won't. So that's just something we would have to change in the future. And that's it. Are there any questions? What's up?
You guys have access to any more precise hardware than Mindstorm?
So you mean in terms of programming the robot, or
In terms of
hardware, right?
I know.
Oh, well, we looked around, and we ended up just going with this one because it was more simple than the other ones to program. But then ultimately the downside was that we only have one joint to rotate on the leg, and that's like, I guess you can call it like his ankle, and it shifts. It doesn't shift forward and backwards, it shifts left and right. So that's why the walking algorithm was kind of different.
Project Identity brings in middle school and high school kids, and they do a robot workshop. So they use the Legos, and so that's another reason they want to use it, so we can show it to them, see what they think also.
We also teach them Alice.
Oh, okay, all
And
right.
run it again. It should pop up on the screen. Yeah, so the guys actually.
So now, see, he's actually on the screen now. So watch, this is what we were talking about. You go ahead. See how he doesn't move? So we're trying to figure out how, I guess with Game Maker, because at first we actually put the executable on each leg to see if it works. So like if you hit the left button, he would activate. But that kind of defeats the purpose because, like Kay and I were talking about, it that kind of shuts down the robot and starts the robot back up each time. So, I mean, the robot should start up one time and then be able to control it through a game. So that's why we just put the executable function within the what do you call it?
The room for the game. Yeah.
Did you ever try working with like a simpler design? See if that would work. Like, say instead of a humanoid, say like this robot with wheels.
Well, the purpose was we wanted a humanoid robot in the first place. So I just built this at the beginning because we were trying to do a walking algorithm. I guess in retrospect, it might have been simpler to start off with something with wheels, just so I could learn how the motor works. But when it came down to it, we had to make a humanoid-looking robot which walked. So
Okay.
Any other questions?
Thank
Thank
very
you.
much.